I'm the head of the Smart Automation Department for more than 20 years as manager on more than 100 research and development projects, funded by administration or subcontracted by private companies, mainly in the field of photonic sensors and process automation in the food industry. Regarding Ainia, we are a technology center whose mission is to bring value to the company by leading innovation and technological development in a responsible and committed way. We are a non-profit organization with more than 700 associated companies and more than 1,500 clients. Our priority lines are food and health, food quality, safety, design, and industrial production, sustainability, environment, and consumer. Our main sector is food, but also we work on energy, packaging, or cosmetic. At Ainia, we are very active in international cooperation in research and development projects, technical assistance, training, and analytical services for official bodies. Our infrastructures have more than 13,000 square meters of facilities for the development of our research activity, with a value of over 30 million euros, including 8 laboratories, 12 pilot plants, classroom research area, industrial supercritical plant, and rooms for consumer studies. 72% of our income comes directly from private companies. The other 28% comes from European, national, and regional research projects. Well, let's talk about the power of light. Electromagnetic radiation interacts with matter. A part is reflected, another part is absorbed, and the other part passes through the sample. With photonic devices, we can use the light after the interaction to measure properties from the matter, physical information like shape or color, or chemical information like composition. Food is a complex matrix, multi-component and variable, depending on its origin, the supplier, or the season. Food is to feed human beings. It's really important to control its quality and safety. Photonic technologies help us to achieve this aim. One of the main photonic technology for us is advanced vision, which consists of the application of sensors able to capture an image from an object in different bands of the spectrum, some of which the human eye is unable to capture. In an image, we can apply conventional image analysis techniques or innovative ones as deep learning, for example. Fluorescence, NNI imaging, laser vision, 3D, LiDAR, time of flight, multispectral vision, thermography, terahertz, or X-ray. Spectroscopy is also a significant photonic technology for us. It consists on the measurement of the interaction between infrared light and food to identify chemical compounds or its concentration. In the case of conventional spectroscopy, we apply microspectrometers in quality control, process optimization, or waste reduction. Chemical imaging or hyperspectral vision is a technology that combines the advantages of machine vision and spectroscopy. It allows to obtain the spectral fingerprint of each point of the sample and measure its composition to optimize the process, classify the product depending on its quality, or to detect contaminants. Of course, complex sensors provides complex data. So we need to analyze this data to extract the information of interest. We are using different techniques to do that, such as machine learning, process analytical technologies, or multivariate analysis. Sorry, there is a. Okay, now my speech corresponds with the image. Well, we want to tell you some success stories or relevant projects we have done. For example, the violin. This was a European project with the aim of developing a biosensor for the rapid detection of Listeria monocytogenes. The result was a system able to recover biofilm from surfaces in contact with food and perform a selective detection in less than 3 hours easily and automatically. Digilab is a developed device by Ainia based on optical technologies to automate the counting process of colonies in microbiological cultures in Petri plates with the reduction of time and cost. In the field of integrity and safety inspection on packaging lines, we have technology to carry out real-time inspection in a bottling line of a small foreign matter, glass or plastic fragments, detecting and quantifying the particles present thanks to the penetrating vision and parallel computing. Ainia has developed a fast and low-cost technology able to measure internal quality and health status of the fruit, internal defects or rottenness, and separate them into different classes, for example, in citrus or melon. Regarding the methodology to automate the control of industrial processes, we have also microspectrometers and hyperspectral cameras able to measure chemical properties of the products. This technology is able to detect contamination in real time over the food products. For example, foreign bodies with different composition, cross-contamination with other compounds, or contaminated or spoiled food. Also, we have technology and a patent for doing the supervision of the sealing process, detecting any variation in the sealing conditions by means of the analysis of thermographic images and environmental conditions. The system is able to detect defects and fails in the sealing area of each package. And another example of a success story is the application of photonic technologies combined with drones and big data for crop optimization. In this case, we have developed a demonstrative model of precision agriculture to characterize crops with the capability to detect pests and diseases. We have integrated the latest hyperspectral vision technologies coupled to autonomous drones and robots and big data analytics. Well, the reason I'm here is because in Ainia, we are interested in promoting the application of photonics in food, doing also networking with many of you, contact with scientific partners or companies to collaborate, and identify new challenges and opportunities in the market that can be solved thanks to photonics. Please do not hesitate to contact with me for any question now or later after the webinar. Thank you very much for your attention.
Okay, thank you very much, Ricardo. Thanks for the nice presentation. And those of you who have questions for Ricardo, you can write them in the chat. It is the icon below with the speech bubble. You can write it here, and I will read it to Ricardo. We have the first one from Juan Maldonado. He asks, is it possible to measure the internal temperature of a product when it comes out from the oven?
Well, the infrared bands, in the case of the measurement of temperature, are not penetrating, cannot penetrate, go deep into the sample. So with thermal cameras, it's quite difficult to measure the internal temperature of the product. You can use conventional thermal cameras, but you have to.
Ricardo, we have lost your voice.
This technology and its capabilities, and perhaps he can answer better than me this question.
Okay, we have lost a bit your voice during 5 seconds. Could you repeat a summary of your answer, please?
Okay, don't worry. I was saying that that the infrared band where we can measure temperature is in the mid-infrared and far infrared, and in these bands the light cannot penetrate the samples, cannot go inside the samples. So it's quite difficult to measure the temperature with thermography, the temperature inside any body, any object. But you can do a model to study the correlation between external and internal temperature, and applying later techniques like machine learning. Anyway, I was saying that Victor Blanco from BCB will speak later more about this technology and its potential for this purpose.
Okay, thank you. We have another question from Kevin Chandler. He says, thanks, Ricardo. Could you comment briefly on which spectral ranges are most interesting for your applications in food control? Which are the spectral ranges more interesting for you?
Okay, for us, it depends on the application. If you need more information about composition, the best band is the shortwave infrared band between 1,000 and more or less 2,000 nanometers. But if you want also to measure properties related with color, then perhaps is more useful use a device between 400 and 1,000 nanometers. So it depends on the application. But when composition is really important, the best band is shortwave infrared.
Okay, thank you, Ricardo. Next question. We have a lot of questions, and we will make short answers and short questions. Fernando Maya, you mentioned the hyperspectral camera in one of your products. What is the range of wavelengths that are you using with this camera?
Okay, I have answered previously. In the case of when we want to go deep inside the sample, we are using infrared between 400 and 1,000, because in this band of the infrared we can go deeper inside the samples. In the shortwave infrared is quite difficult to go deeper, to penetrate inside the samples.
Okay, Luis, he says, could some of these technologies be used to detect flies or other insects inside a bottle, for example?
Well, of course, it depends on the bottle, but in general, we have good experiences with bottled wines and also with champagne bottles, and with combining machine vision algorithms with infrared cameras in some specific bands, we can detect this kind of insects.
Okay, Colin Barnham, is there any application that you would like to be able to do today, but the photonics technology still does not permit? What is coming in the future?
Well, I think one issue interesting for everybody is to penetrate more inside solid samples. This is an interesting issue in general for everybody, all the universities and research centers, and perhaps to have sensors affordable in cost, not too much expensive, in the band of the shortwave infrared, because the devices over 1,700 nanometers are really, really expensive.
Okay, Jordi asks, what is the bottleneck in inline food inspection? He's thinking about, for example, fruit inspection in line with such as oranges. Is the bottleneck speed, sensitivity, the available wavelength ranges?
Well, now there are very good machines, the commercial machines in the market for external properties, for defects, for color measurement, for defect detection, but not for internal properties. Internal properties, I think this is currently the main goal to be solved in industrial machines. Perhaps this is now the bottleneck.
Okay, we have more questions, much more questions. What we are going to do is, if you agree, in the next 2 days, to put you in contact, those people who are doing the questions with Ricardo, sending him the question for him to answer with more time, okay? Because now the time is over, but we will make the matchmaking, okay?
Okay, thank you very much. Please do not hesitate to contact with me later by email or calling me. Thank you very much.
Okay, Ricardo, you can write in the chat your email for all of them to have it, okay?
Okay.
Thank you very much. Thank you.